My name is Laura, and today I'll be going over this homework problem from homework number 7, spring 2025, and this problem is 7.6. So, given the H field equals x hat times zero point 0.1 times sine 3000t plus 40y, find the frequency the wave is oscillating at and the wavelength in this medium, and the corresponding electric field E. So I went ahead and highlighted the important things we need to do. I highlighted the H field equation as well as the different things we need to find. And then before going into this problem, just want to review different properties that we will be using. So this is all taken from the textbook. The electric field and H field are always in phase, and they all are perpendicular from each other. And this is the E field, the H field, and K, which is our propagation. So the direction in which the signal is moving towards. And they are in cyclical permutation following the right-hand rule. And you can rewrite this as a cross product. And then the property is the ratio of the E field constant over the H field constant equals the wave impedance eta. And that can also be written as the square root of mu over epsilon. And in a vacuum, eta naught equals 377, which we use. And this ratio equals the phase velocity. And this is important as we use for non-magnetic materials. V equals C over square root of epsilon r, which equals C over n. And n is our index of refraction, which equals also the square root of epsilon. And then looking at this diagram, we can see what this equation actually means, this cross product, as they are all 90 degrees away from each other. So our electric field is on our x-axis in the positive direction, and our y is in the positive direction, our H field is in that one direction, and our propagation is going along the z-axis in the positive direction. So we can see that they are all 90 degrees away from each other, and that will help us figure out the E field. Let's go over what this equation is actually telling us. So this is our H field, and it's equal to x hat 0.1 sine 3000t plus 40y. So this first part right here, x hat, is telling the direction of the H field. 0.1 is our constant, our magnitude, and this part, sine, is the phase of the equation. So this is written in the omega t minus k y format, where omega is our angular frequency, t is our time, k is our wave number, and y is the position. So if we were to rewrite this equation in this format, we could rewrite it as 3000 t minus negative 40y. And you can also rewrite this as 40 times negative y. And I'm rewriting it in this way because it helps us determine what our k value actually is, which is still 40, but the direction is in the negative y-axis. And then we can rewrite that our omega value is 3000. So our first thing we need to find is the frequency at which this wave is oscillating at. And we can find that by using the equation F frequency equals omega over 2 pi. And so since we know what our omega is, this is easy to find. So this will just be 3,000 over 2 pi. And that equals 477 hertz. So yeah, our frequency is going to be in the hertz unit. So this is the first thing we found. So I'm just going to go ahead and highlight, get that out of the way. And now our second thing we need to find is the wavelength in this medium. So this is found, we can use our K value or propagation value. And so K equals 2 pi over lambda. And lambda is the wavelength. So this is the relationship between the two of them. And we can rewrite this to find our lambda value. So that will be lambda equals 2 pi over K. And then rewrite this with what we know, which is 2 pi over 40. And we get the lambda wavelength value as 0.157, and the units will be in meters. Okay, so now I'm just going to highlight this in a different color. So now we have our wavelength. And so now we have to figure out our corresponding electric field value. So before we do this, we need to find, let's draw a diagram. So this is going to be my X and Y axis. And using the right-hand rule, if this is the positive and this is also the positive, then we can find that our Z will be coming out of the page. And that is denoted by a circle or a dot right here. And I think of this as kind of an arrow. So if you would see an arrow going out of the page, it would look like a dot. And then into the page is kind of like the tail. So this is into the page, which is an X. So now we know our directions. We can write our H field and our K. So looking at this equation over here, we see that it has X hat. So that means our H field is going in the X direction. So I'm going to use blue. Okay, so this is our H. And then now we want to write our K. So again, looking at this, our K is in the negative Y direction. So if this is positive, this way will be negative. So you can write that like this. So now that we know our H and our K, we can find our E. So again, using our right-hand rule, knowing that E cross H equals K, using right-hand rule, we figure out that our E field is going into the page. So using the cross to denote that. And so that means our E is going to be negative Z, since Z going out of the page is our positive. We said E and H are always in phase. So that means this part of the equation, let me highlight that. This part of the equation will be staying the same because the propagation direction is going to be the same. And since it's in phase, the frequency is also going to be the same. So let me rewrite this. And so we got the direction, which is negative c hat. And then we also have the sine (3000t) plus 40. And all we need is our E naught, which is our constant that will be right here. So our E naught value, as one of the properties determined, E naught over H naught equals the wave impedance eta. And so we can rewrite that as E naught equals eta times H naught. And we know our H naught is 0.1 according to our H field equation. So we can go ahead and just write that down here. But we still need to determine our eta. And that can be figured out by using the equation eta equals eta naught over square root of epsilon. And our epsilon r is basically equals to n. And so we can use this set of equations. So we know V equals omega over k, which equals to c over n. And we know now c over epsilon r. And so we have our omega value, our k value, and c is a constant that equals 3 times 10 to the power of 8. And so now we'll be able to figure out our epsilon. So omega over k is 3000 over 40. And c, as I said before, is 3 times 10 to the power of 8. And so we have epsilon r. And we can rewrite that as epsilon r equals, so 3000 over 40 is 75. So this is 3 times 10 to the power of 8 over 75. And we can just leave it like this and put it into the other equation. And as I said before, eta naught is 377. So we can rewrite this as 377 times 75. This is us plugging in square root of epsilon r. And since that's this value over here, you just put it there. And so that is over 3 times 10 to the power of 8. And we get that equal to 9.4 times 10 to the power of negative 5. Okay, and now that we have this value, we can put it into this equation. So we can rewrite this as 9.4 times 10 to the power of negative 5 times 0.1, which will give us 9.4 times 10 to the power of negative 6. So now that we have our E naught value, we can plug it into this equation. So I'm going to rewrite that. So we have our E field equation equal to negative c hat times 9.4 times 10 to the power of -6 sine 3000 p plus 40 y, and our units are v over n.